Hello class, this is Ms. Radians with today's video on section 8.1 Radians and Arc Length. As you're watching the video, write down important notes, equations, statements, examples, or questions you may have, and feel free to pause, rewind, or replay the video as often as you need so that you can get a clear understanding about what's going on. When you have concluded watching the video, write down a brief summary about what occurred in the video in your notes and submit that summary as well as a top question via the online whisk the day before class. All right, let's begin. Today's unit is actually going to be something from my understanding you guys already have experience with being in Korea, but I'm going to teach it to you as if you've never seen it before. So hopefully your understanding will be solidified or improved because of it for those people who have seen it before. And if you haven't seen it before, this will be a good introduction to something. So today I'm going to be using GeoGebra to illustrate this concept. So I have a circle of a various radius. In this case, I've set the radius to be 5. And I can determine the circumference by using the distance tool and clicking anywhere on the circle. And it gives me the circumference of this circle, which is around 31.42. Okay. But what if I want to look at how long a portion of the circle is? So that's called an arc. So I'm going to select 2 points A and B that are on this circle. Move it around so we get a better CB. And let's find the measure of the distance between the two, which is, of course, a straight line, which is AB. But if I want to find what part of the circle is in between A and B, then I have to measure the arc length. And so in order to do that, I need to get rid of the circle because GeoGebra makes it hard to measure it if you have a circle underneath. I'm going to still use the distance tool. I still have the distance tool selected. And then I'm going to just click somewhere on that arc. And it gives me that the arc length is 7.79 units out of 31.42. And if I were to take a look at bring back the circle and then bring a sector that shades it, it gives me an idea about the percentage of the circle that this sector and this arc length is. And it looks to be about 1/4 of the circle, and we can calculate that by doing several things. We can take the arc length of 7.79, and again, this is an approximation, so to the 100th place, and we get around 24.79%. So we were right, it's about approximately 1/4. So here's a question that I have, and the question is, what percentage of the circle would the arc be that has the same measure as the radius? Okay. In other words, my radius is 5. I wonder what portion of the circle would be if I had a radius of 5, if I made the arc length that same radius. And I know some of you can say, well, all you got to do is just divide the circumference of the circle by 5 units, which is the radius. And when I do that, I already know what the percentage is, but let's take a look at what that represents graphically or visually so we can get an idea, which is about 15.9%. So I'm going to change B so I can get an arc length of 5. Oops, almost there. Oops, and my battery's running low. Sorry. Let me pause it. Okay, I'm back. I had to plug the charger in. So anyway, I get here here is the the arc length that is produced that has a radius of exactly the same length as the the exact same length as the radius, and that's what it looks like. And our calculator said it's about 15.9% of the circle. And if I wanted to know how many of these arcs can I fit around the entire circle, I can do that by either estimating it, or I can say, well, I can just divide 31.42 divided by 5. And I get around an answer that looks very familiar. It looks around 6.28. And this occurs no matter what the radius of the circle is. If I were to divide the circumference by the arc length, I would get around 6.28, which makes sense because the formula for circumference involves the radius. So I get around 6.28, which is around 2 pi. But now my question is, what's the measure of the degree of the angle that produces that arc? And so I can measure an angle very easily by going to the measuring tool and measuring angle. And clicking, remember we talked about counterclockwise, so we're going to do A, B, and C. And I get a measurement of around 5.732 degrees, which is approximately 60 degrees or 1/6 of the circle, which is consistent with what we found earlier. And this occurs no matter what size the circle is. We still get the matching arc and the matching with the radius, but the angle measurement, let me move these out the way, sorry. I'll leave that here. It's still around 1/6, and even if we get it all the way down to the unit circle. So now, and it takes how many of these to get around the entire circle? Well, some of you may remember I just said around 6.28 units, which is approximately 2 pi. So now we have a definition for a radian based off this explanation. And so that definition looks something like this. A radian is the measure of the angle that will produce an arc length that is the exact same length as the radius of the circle. Okay, so 1 radian is the angle measurement that will produce an arc length that is the exact same length as the radius of the circle. And visually, that's what it represents. And the definition is an angle of 1 radian is defined to be the angle in the counterclockwise direction. All right. At the center of a unit circle, which spans an arc length of 1. So therefore, 2 radians would be defined to be the angle at the center of the circle, which spans an arc length of 2 units, and vice versa. And we know that 6.28 radians, or 2 pi radians, would span the entire circle, as we saw before. Okay, so that's the definition of a radian. It's an angle measure, a way to measure an angle based off of the arc length that produces a length the same as the radius. So of course we can use the conversion that since the entire circle is 360 degrees and the entire circle is also 2 pi radians, then that's the relationship. You can also use 180 degrees is equal to pi radians or vice versa, and that's sufficient. So however you want to look at it, we use this relationship between the two. So 1 radian is equal to 180 degrees divided by pi, which is how we end up with 57 point something degrees. And we can get that relationship from this relationship. Now, interesting enough, remember we said we were able to measure the length around the entire circle as circumference. Another way to measure the length of an arc is also involving the radius and the radians. I mean, the angle that's used to produce that. So it's called S is the arc length of the length of an arc spanned by a circle with radius R to be an angle of pi radians. So we can figure out the arc length by multiplying the radius times the angle in radians that is produced by that arc length. And as we saw, that's consistent with our example. So if you recall, we talked about in the example, we had an arc length of 5 units, and we could use this relationship to explain that be equal to the radius, which was also 5 units, times 1. And we're not going to put a symbol like in degrees. We're going to refer to it as being 1 radian, okay, as well. And so that's consistent with what we did. Now let's take a look at some examples. Let's convert 30 degrees to radians and pi over 9 radians to degrees. And one of the easiest ways is to use this relationship. Degrees times pi over 180 is equal to radians, and radians times 180 over pi is equal to degrees. And so if we take a look at 30 degrees, we use pi times 180, and we get, using simplifying, pi over 6 radians is our answer. Okay, same thing over here. We have pi over 9, but there's no units, but we know that's radians. We multiply that times 180 degrees over pi, which is the conversion rate, and then we end up simplifying it, and we end up with 20 degrees. Okay. All right, so in conclusion, I really want you to get really comfortable with using radians, because probably after this unit, we won't be using degrees anymore. We'll be using radians. So just like you are really comfortable with the measures of degrees of a circle, you should get comfortable, really comfortable with the measures of radians of a circle as well. And so this chart always helps. I would learn the purple ones first. Those are easy. Then I would learn the more popular ones as we see, and also get comfortable with memorizing it. So at the end, if someone were to tell you 120 degrees, in the past you would know where it is. Now if they tell you what's 5/6 pi angle measurement, you would be able to identify it too. And for now, when they ask you questions about which quadrant is this radian measuring and which quadrant is this one, it might be okay for you to convert it to degrees so you'll have an idea of where the angle is. But you should really get familiar with the radian measures, just as familiar as you are with the cosine measurements. I'm sorry, with the degree measurements, okay? And I think that was it. This is a shorter video, but even though I did some examples as well. So you might want to get comfortable with converting your calculator back into radians, so that because we'll be using this after this unit. All right, have a good day.